There is something that they didn't teach you in school about our solar system. Wherever you are in the world, whatever time it is, you're about to discover something extraordinary. We're going on a journey that will take us far beyond anything you learned in those dusty textbooks, beyond the simple diagrams of 9 planets orbiting the Sun, beyond the basic facts they fed you about Mercury being hot and Pluto being cold. Because here's the thing they never told you in school. Our solar system isn't just a collection of rocks floating in space. It's a cosmic neighborhood so strange, so beautiful, and so utterly mind-bending that even our most brilliant scientists are still trying to understand it. If you find comfort in these gentle explorations of space and science, I'd be grateful if you consider subscribing and giving this video a like. The visuals are here for you, but feel free to close your eyes, breathe deep, and let your imagination drift through the solar winds as we uncover truths that will reshape everything you thought you knew. I should warn you, this video might be just too interesting to not skip and to consider watching till the end. It might accidentally keep you awake. I'd love to know where you're watching from tonight and what time it is for you. Feel free to drop your location and time in the comments below. Let's start. You're sitting in your 4th grade classroom, staring at that familiar poster on the wall. You know the one. 9 perfect spheres lined up in a neat row, each one a different size and color, with the sun blazing cheerfully on the left. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and little Pluto bringing up the rear. Your teacher points to each one with a wooden stick, reciting the same facts that have been repeated in classrooms for decades. But what if I told you that nearly everything on that poster was wrong? Not just incomplete, not just oversimplified. Actually fundamentally wrong about the true nature of our cosmic home. The solar system you learned about in school doesn't exist. It never did. It was a convenient fiction, a simplified story we tell children because the truth is so much stranger, so much more complex, that it would have blown your young mind into cosmic dust. Tonight, we're going to shatter that comfortable illusion and reveal the solar system as it really is. A place where diamond rain falls from alien skies, where moons have oceans deeper than anything on Earth, where planets wander like cosmic nomads, switching places in a gravitational dance that spans millions of years, where the very definition of what makes a planet has been rewritten by discoveries so shocking that astronomers are still arguing about them. This isn't just about learning new facts. This is about fundamentally rewiring how you understand our place in the universe. Because once you see the solar system as it truly is, you'll never look at the night sky the same way again. Let me start with something that will make you question everything. That neat, orderly arrangement of planets in your textbook. It's a lie. Our solar system isn't a cosmic train with planets following predictable tracks around the sun. It's chaos. Beautiful, elegant chaos. Right now, as you're listening to this, our entire solar system is hurtling through space at over 500,000 miles per hour. Not orbiting, not sitting still, racing through the galaxy like a cosmic bullet, carrying all of us along for the ride. The sun isn't the center of anything except our local gravitational dance. We're all passengers on a starship called Sol, flying through an ocean of darkness toward a destination none of us will live to see. But that's just the beginning. Remember how they taught you that planets orbit the sun in perfect circles? Wrong again. The orbits are elliptical, sure, but even that's misleading, because orbits aren't fixed paths carved into the fabric of space. They're dynamic, ever-changing relationships between massive objects that are constantly influencing each other. Jupiter, that giant ball of gas you learned about, isn't just sitting there looking pretty. It's a cosmic vacuum cleaner, a gravitational monster that has spent billions of years protecting Earth from asteroid impacts. Without Jupiter's massive presence, our planet would have been pummeled into sterile rock long before life had a chance to evolve. That giant red spot on its surface, it's not just a storm, it's a hurricane larger than 3 Earths that has been raging for over 300 years. A tempest so vast and violent that it makes every natural disaster in human history look like a gentle summer breeze. And Saturn, those beautiful rings they showed you in pictures, they're not solid, they're not permanent, they're made of billions of chunks of ice and rock, some as small as pebbles, others as large as mountains, all locked in an intricate gravitational ballet that creates patterns so complex mathematicians are still trying to decode them. Those rings are constantly changing, constantly reshaping themselves. In cosmic terms, they're as temporary as morning mist. But here's where it gets really weird. Those rings might not even be natural. Some scientists now believe they could be the shattered remains of ancient moons that wandered too close to Saturn's gravitational embrace. Imagine that. What we see as one of the most beautiful sights in the solar system might actually be a cosmic graveyard. Let's talk about Mars for a moment. That red planet you learned about as Earth's smaller, colder neighbor. They probably told you it was red because of iron oxide, basically rust. They might have mentioned that it has polar ice caps, and maybe even hinted that it might once have had water, but they didn't tell you that Mars used to be more like Earth than any planet in our solar system. They didn't tell you that billions of years ago, Mars had a thick atmosphere, flowing rivers, and possibly even rain. They didn't tell you that something catastrophic happened to Mars. Something so devastating that it stripped away most of its atmosphere and turned a world that might have harbored life into the frozen desert we see today. And here's the terrifying part. Whatever happened to Mars could happen to Earth. We're still not entirely sure what caused Mars to lose its atmosphere, but the leading theories involve either a massive asteroid impact or the gradual loss of its magnetic field. Both scenarios are not just possible for Earth, they're inevitable, given enough time. But let's venture even further from the comfortable lies of your childhood education. Remember how they taught you that our solar system has 9 planets? Then suddenly it was 8 when they demoted poor Pluto. Well, brace yourself because the real number might be closer to several hundred. You see, out beyond Neptune, in the frozen reaches of space that your textbooks barely mentioned, there's an entire population of worlds. They're called dwarf planets, and they outnumber the traditional planets by a massive margin. Ceres, Eris, Makemake, Haumea, and yes, Pluto. These aren't just large asteroids or chunks of ice, they're legitimate worlds with their own unique characteristics, their own mysteries, their own stories waiting to be told. Ceres, for instance, is located in the asteroid belt between Mars and Jupiter. But it's not just another space rock. It's a world with a complex geology, possibly harboring more fresh water than exists on Earth. There are mysterious bright spots on its surface that still puzzle scientists. Some think they might be salt deposits left behind by ancient geysers. Others speculate they could be something even more exotic. And then there's Eris, a world so distant and so cold that it takes over 500 Earth years to complete one orbit around the Sun. Its discovery in 2005 was what triggered the Great Planet debate that led to Pluto's reclassification. But Eris isn't just famous for causing controversy. It's actually more massive than Pluto and has a moon of its own, a dark companion called Dysnomia that orbits in perfect synchronization with its parent world. But perhaps the most intriguing of these distant worlds is Haumea, a dwarf planet that's shaped like an elongated football and spins so fast that a day there lasts only 4 hours. It has 2 small moons and a ring system that was only discovered in 2017. Imagine that. We're still finding ring systems in our own solar system. How's that for humbling? Now, let me blow your mind with something they definitely didn't teach you in school. Our solar system might have more than 8 or even hundreds of planets. It might have thousands, possibly millions. In the outermost reaches of our solar system, in a region called the Oort cloud, there exists a spherical shell of icy objects that extends nearly a quarter of the way to the nearest star. This isn't speculation. This is where comets come from. When you see a comet streaking across the sky, you're watching a visitor from the edge of our solar system, a chunk of primordial ice and rock that has been nudged out of its distant orbit and sent on a collision course with the inner solar system. But here's the kicker. Some of these Oort cloud objects might be large enough to qualify as planets. We just don't know because they're so far away and so dark that our telescopes can barely detect them. There could be Earth-sized worlds out there, cold and dark and ancient, orbiting our sun at distances so vast that they receive less sunlight than a candle flame provides from across a football field. And that's not even the strangest part. Some scientists believe there might be a 9th planet lurking in the outer solar system. Not Pluto, which we've reclassified as a dwarf planet, but a genuine, massive world that we haven't discovered yet. They call it Planet 9, and the evidence for its existence comes from the strange behavior of objects in the outer solar system. You see, these distant objects seem to be clustering together in ways that don't make sense unless there's a large, unseen gravitational influence shepherding them into these patterns. Computer models suggest that Planet 9, if it exists, would be about 10 times more massive than Earth and orbit the Sun at a distance 50 times farther than Neptune. Think about that for a moment. There might be a world in our solar system larger than Earth that we haven't even discovered yet. A dark, cold giant wandering the outer reaches of our cosmic neighborhood, invisible to our telescopes, detectable only by its gravitational fingerprints on smaller worlds. But let's bring this journey back to something more familiar, something closer to home. Let's talk about our moon, that friendly, familiar companion that lights up our night sky and controls our tides. They probably taught you that the moon formed when Earth collided with another planet-sized object early in our solar system's history. That much is true, but they probably didn't tell you just how violent and catastrophic that collision was, or how incredibly lucky we are that it happened the way it did. The object that created our moon, which scientists call Theia, was roughly the size of Mars. When it slammed into the early Earth, the impact was so powerful that it literally melted both worlds, creating a massive cloud of molten rock and metal that eventually coalesced into the Earth-Moon system we know today. But here's what makes this story even more remarkable. The angle and speed of that collision had to be absolutely perfect. Too steep, and Theia would have shattered Earth completely. Too shallow, and it would have bounced off, leaving us with no moon at all. The impact had to be just right to create a moon that's the perfect size and distance to stabilize Earth's rotation and create the tidal forces that may have been essential for the development of life. Without our moon, Earth would be a very different place. Our days would be much shorter, probably only 6 to 8 hours long. Our planet would wobble chaotically on its axis, causing extreme climate variations. The tides, which scientists believe played a crucial role in helping early life transition from ocean to land, would be nearly non-existent. In other words, that catastrophic collision that created our moon wasn't just a random cosmic accident. It was the single most important event in the history of life on Earth. And it happened through a series of coincidences so improbable that some scientists wonder if we're living in a universe specifically fine-tuned for our existence. But our moon holds even more secrets than its violent origin story. Recent discoveries have revealed that it's not the dead, airless rock we once thought it was. There's water ice at the lunar poles, possibly billions of tons of it, locked away in permanently shadowed craters that haven't seen sunlight for billions of years. Even more intriguing, our moon experiences what scientists call moonquakes. These aren't caused by tectonic activity like earthquakes on our planet. Instead, they're triggered by the gravitational pull of Earth itself, causing the moon's interior to flex and crack in ways we're only beginning to understand. And here's something that will make you look at the full moon differently. Our moon is gradually moving away from Earth. Every year, it drifts about 1.5 inches farther from our planet. In the distant future, billions of years from now, the moon will appear much smaller in our sky, and total solar eclipses will become impossible. But that's not the most mind-bending part of our moon story. The most incredible thing about our moon is how perfectly it aligns with our sun during eclipses. This isn't a coincidence that happens occasionally. It's a nearly perfect match that occurs because our moon appears to be exactly the same size as our sun when viewed from Earth's surface. Think about how improbable that is. Our sun is 400 times larger than our moon, but it's also 400 times farther away. This creates an optical illusion so perfect that during a total solar eclipse, the moon blocks out the sun's bright disk, while allowing us to see the sun's corona, its ethereal outer atmosphere. This cosmic coincidence is so remarkable that some scientists call it the most beautiful accident in the universe. But is it really an accident? The mathematical precision required for this alignment to work so perfectly has led some researchers to wonder if there might be deeper principles at work in the universe, forces or laws that we don't yet understand. As we continue our journey through the hidden truths of our solar system, remember that every fact I'm sharing with you represents a fundamental shift in how we understand our cosmic home. The solar system isn't just a collection of worlds orbiting a star. It's a dynamic, ever-changing system where every object influences every other object in ways both subtle and profound. And now, let me take you to a place that will completely redefine what you think you know about life in our solar system. A place so extraordinary that when scientists first discovered what was hiding there, they had to rewrite the textbooks on where life might exist in the universe. I'm talking about Europa, one of Jupiter's moons. In school, they probably mentioned it as just another chunk of ice orbiting the gas giant. Maybe they showed you a picture of its smooth, white surface and moved on to something else. But they didn't tell you that beneath that frozen exterior lies an ocean that contains more water than all of Earth's oceans combined. Think about that for a moment. More water than exists on our entire planet, locked away beneath the ice of a moon that's smaller than our own. But this isn't just any ocean. This is a dark alien sea that has existed for billions of years, kept liquid by the immense gravitational forces that Europa experiences as it orbits Jupiter. Those forces don't just keep the water from freezing, they create something even more remarkable. As Europa gets stretched and squeezed by Jupiter's gravity, the friction generates heat in the moon's rocky core. This heat powers hydrothermal vents on the ocean floor, similar to the ones we find in Earth's deepest trenches. And here's where it gets truly extraordinary. Those hydrothermal vents on Earth, they're teeming with life. We're not talking about simple bacteria here. We're talking about entire ecosystems that exist in complete darkness, deriving energy not from sunlight, but from chemical processes. Giant tube worms, ghostly crabs, and microorganisms that thrive in conditions that would instantly kill most life on Earth's surface. If similar vents exist on Europa's ocean floor, and there's every reason to believe they do, then Europa might be home to alien life forms that have been evolving in isolation for billions of years. Life forms that have never seen sunlight, never breathed oxygen, never experienced anything remotely like the conditions we consider normal for life. But Europa isn't the only moon harboring hidden oceans. Enceladus, one of Saturn's smaller moons, has been shooting geysers of water and organic compounds into space through cracks in its south polar region. When the Cassini spacecraft flew through these geysers, it detected not just water, but complex organic molecules, the building blocks of life as we know it. Imagine that. We have moons in our solar system that are literally spraying the ingredients for life into space. And these aren't just theoretical possibilities. These are active, dynamic worlds where the conditions for life might exist right now, as you're listening to these words. Titan, Saturn's largest moon, presents an even stranger possibility. It's the only moon in our solar system with a thick atmosphere, and that atmosphere is constantly raining. But it's not water that falls from Titan's orange skies. It's liquid methane and ethane, creating rivers and lakes of hydrocarbons that flow across a landscape that looks eerily similar to Earth. The temperatures on Titan are so cold that water ice is as hard as granite, forming the bedrock of this alien world. But in those methane lakes, in that hydrocarbon rain, some scientists believe we might find forms of life so exotic that they would redefine our understanding of biology itself. These wouldn't be life forms based on water and carbon like everything we know on Earth. They would be methane-based organisms, possibly using different chemical processes entirely. Life forms that would find Earth's environment as hostile as we would find theirs. Now, let me share something with you that will fundamentally change how you think about planetary formation and the early history of our solar system. Remember how they taught you that the planets formed in their current positions, with the small rocky worlds close to the Sun and the gas giants farther out? That's not what happened, not even close. Our solar system went through a period of absolute chaos called the Late Heavy Bombardment, and it was so violent, so catastrophic, that it nearly destroyed everything that had formed up to that point. This wasn't just a few asteroid impacts. This was a cosmic demolition derby that lasted for hundreds of millions of years. During this period, the giant planets didn't stay in their nice, orderly orbits. They migrated. Jupiter moved inward toward the Sun, while Saturn, Uranus, and Neptune scattered outward like cosmic billiard balls. As they moved, their gravitational influence sent millions of asteroids and comets careening through the inner solar system. The evidence for this chaos is written on every solid surface in our solar system. The Moon's craters, Mars's battered landscape, Mercury's scarred face. They're all testimony to a time when our solar system was a shooting gallery of death and destruction. But here's the truly mind-bending part. Some scientists believe that Jupiter's inward migration might have destroyed an entire generation of planets that formed closer to the Sun. Worlds that might have been Earth-like, worlds that might have harbored early forms of life, all swept away by the gravitational chaos of the migrating giants. We might not be the first attempt at life in our solar system. We might be the second, or the third, or the 10th. Previous worlds, previous attempts at complexity and consciousness might have been wiped clean by cosmic forces so vast that they left no trace of their existence. This migration theory also explains something that puzzled astronomers for decades. Why is Mars so small compared to Earth and Venus? computer models now suggest that Jupiter's inward journey prevented Mars from accumulating the material it needed to become a full-sized planet. In a very real sense, Jupiter stunted Mars's growth, leaving it as a cosmic runt that never reached its full potential. But Jupiter's influence on our solar system goes far beyond planetary migration. Right now, as you're sitting there listening to this, Jupiter is protecting Earth from cosmic impacts in ways that are almost impossible to comprehend. You see, Jupiter acts like a gravitational shepherd, corralling asteroids and comets that might otherwise find their way into the inner solar system. Its massive gravitational field either captures these objects entirely or flings them out into interstellar space. Without Jupiter's protection, Earth would be bombarded by large impacts roughly every few million years, instead of every few 100 million years. Think about what that means for the development of life on our planet. Complex life requires stability, time to evolve and adapt. If Earth were constantly being sterilized by massive impacts, life might never have progressed beyond simple microorganisms. We owe our existence not just to the perfect conditions on Earth, but to the gravitational protection provided by a gas giant that sits 5 times farther from the Sun than we do. But Jupiter holds secrets that go far beyond its role as cosmic protector. Deep within its massive atmosphere, conditions exist that are unlike anything else in our solar system. The pressure and temperature at Jupiter's core are so extreme that hydrogen, the most common element in the universe, behaves in ways that seem to violate the laws of physics as we understand them. At Jupiter's core, hydrogen becomes metallic. Not just hot, not just compressed, but actually metallic, conducting electricity like copper wire. This metallic hydrogen generates Jupiter's massive magnetic field, a protective bubble that extends far beyond the planet itself and traps charged particles from the solar wind. The energy contained within Jupiter's magnetic field is so enormous that if we could somehow harness it, it would power human civilization for millions of years. But that same magnetic field creates radiation levels around Jupiter that would kill an unprotected human in minutes. The space around Jupiter is more hostile to life than the surface of the Sun. Yet within this hellish environment, Jupiter's moons have carved out their own unique niches. Io, the innermost of Jupiter's large moons, is the most volcanically active world in the solar system. Its surface is constantly being reshaped by sulfur volcanoes that shoot plumes of material hundreds of miles into space. The volcanic activity on Io is so intense that the moon essentially turns itself inside out every million years or so. Nothing on its surface is older than that. It's a world in constant, violent renewal, powered by the same gravitational forces that keep Europa's ocean liquid. But perhaps the most shocking discovery about our solar system is something that challenges our most basic assumptions about planetary formation and the distribution of elements throughout the cosmos. Deep within the atmospheres of Neptune and Uranus, it literally rains diamonds. The pressure and temperature conditions in these ice giants are so extreme that carbon atoms are compressed and heated until they form diamond crystals. These diamonds then fall like rain through the thick atmospheres, possibly accumulating in vast diamond seas at the planet's cores. We're not talking about small gemstones here. We're talking about diamond hailstones the size of marbles, possibly even larger, falling through alien skies for thousands of miles before settling into oceans of liquid diamond. The total amount of diamond within these planets might exceed all the carbon on Earth. This discovery has forced scientists to reconsider everything they thought they knew about planetary formation and the behavior of matter under extreme conditions. It suggests that our solar system contains forms of matter and conditions that exist nowhere else in our immediate cosmic neighborhood. But the strangest thing about these diamond rains isn't their existence. It's what they tell us about the fundamental nature of our solar system. These aren't rare, exotic phenomena. They're probably happening right now as you're listening to these words. Diamond rain is falling through alien skies in the outer reaches of our solar system, and it has been falling for billions of years. This is the solar system they didn't teach you about in school. Not a neat, orderly collection of worlds following predictable patterns, but a cosmic carnival of wonders so strange that they challenge our ability to imagine them. A place where ice burns, where moons have deeper oceans than our planet, where planets migrate like cosmic nomads, and where diamonds fall like rain from alien skies. Every world in our solar system tells a story that's more remarkable than any science fiction ever written. Because unlike fiction, these stories are real. They're happening right now in the cosmic neighborhood we call home. And we've only just begun to read the first chapters of these incredible tales. As we venture deeper into these hidden truths, remember that each discovery doesn't just add to our knowledge. It fundamentally changes how we understand our place in the universe. We're not just inhabitants of Earth. We're citizens of a solar system so rich with mystery and wonder that we may never fully comprehend all its secrets. And now, let me take you to perhaps the most haunting mystery lurking in the shadows of our solar system. Something so unsettling that it keeps astronomers awake at night, staring at their data with a mixture of fascination and dread. There's something out there. Something massive. Something that shouldn't exist according to everything we thought we knew about how solar systems form. They call it the Kuiper Cliff, and it represents one of the most profound puzzles in planetary science. Picture this. You're mapping the outer reaches of our solar system, cataloguing the thousands of icy objects that orbit beyond Neptune. You expect to find these objects scattered throughout space in a relatively even distribution, gradually thinning out as you move farther from the sun. That's what the laws of physics predict. That's what computer models suggest should happen. But that's not what we find. Instead, at a distance of about 50 astronomical units from the sun, the population of these objects doesn't just thin out, it vanishes completely. As if someone drew a line in space and declared that nothing could exist beyond it. This isn't a gradual fade. This isn't a natural tapering off. This is an abrupt, dramatic cliff where objects that should exist simply don't, and no one knows why. Some scientists believe this cliff might be evidence of a massive gravitational disruption that occurred early in our solar system's history. Perhaps a passing star came close enough to gravitationally strip away everything beyond this boundary. Or maybe it's evidence of Planet 9, that hypothetical giant world lurking in the outer darkness, using its gravitational influence to sweep the region clean. But here's what makes the Kuiper Cliff truly unsettling. If something could carve such a precise boundary in the architecture of our solar system, what does that tell us about the forces at work in the cosmos? What kind of event could be so powerful, so precise, that it could essentially erase entire populations of worlds from existence? The implications stretch far beyond our own cosmic neighborhood. If our solar system experienced such a dramatic disruption, how many other solar systems have been similarly affected? How many worlds, how many potential homes for life have been swept away by cosmic forces we're only beginning to understand? But let's shift our focus to something even more fundamental. Something that challenges the very definition of what we consider normal in planetary science. I want to tell you about the most extreme world in our solar system, a place so hostile, so utterly alien, that it makes the surface of Venus look like a tropical paradise. That world is Io, Jupiter's innermost large moon. From a distance, Io looks almost benign, a yellowish-orange sphere roughly the size of our own moon. But don't let its appearance fool you. Io is quite literally hell made manifest in our solar system. The surface of Io is constantly being torn apart and rebuilt by volcanic forces so powerful they defy comprehension. We're not talking about the occasional eruption like you might see on Earth. We're talking about hundreds of active volcanoes erupting simultaneously, shooting plumes of sulfur and sulfur dioxide hundreds of miles into space. The volcanic activity on Io is so intense that the moon essentially recreates its entire surface every million years. Nothing you see on Io today existed when dinosaurs walked the Earth. The landscape is in constant violent flux, painted in brilliant yellows, oranges and reds by sulfur compounds that rain down from the volcanic plumes. But here's what makes Io truly extraordinary. This isn't volcanism driven by radioactive decay like we see on Earth. This is volcanism powered by gravity itself. As Io orbits Jupiter, the massive planet's gravitational field stretches and squeezes the moon like a cosmic stress ball. This constant flexing generates so much heat that Io's interior remains molten, feeding the endless volcanic fury on its surface. The amount of energy being dissipated on Io is staggering. The moon generates more heat per unit area than any other solid body in the solar system. If you could somehow stand on Io's surface, which you couldn't because the radiation would kill you in seconds, you would witness a landscape that's literally glowing with its own heat, painted in colors that exist nowhere else in our cosmic neighborhood. But Io's volcanic activity affects more than just the moon itself. Those massive eruptions launch material into space with such force that it forms a donut-shaped cloud of particles around Jupiter's entire orbit. This creates an aurora around Jupiter that's visible from Earth, a light show powered by volcanic fury occurring 500 million miles away. Now, let me share something with you that will fundamentally alter how you think about the age and stability of our solar system. Remember how they taught you that our solar system formed 4.6 billion years ago and has remained relatively stable ever since? That the planets settled into their orbits and have been following the same paths ever since? That's not just wrong, it's spectacularly wrong. Our solar system is still forming, it's still evolving, it's still changing in ways that are both subtle and dramatic. The gravitational dance between the planets creates what scientists call orbital resonances, patterns of influence that can accumulate over millions of years to produce sudden, dramatic changes in planetary orbits. Jupiter and Saturn, for instance, are locked in a complex gravitational relationship that causes their orbits to shift slightly over vast periods of time. When these shifts reach certain critical points, they can trigger massive reorganizations of the entire outer solar system. Computer models suggest that our solar system undergoes these major reorganizations roughly every few 100 million years. During these periods, asteroids get flung into new orbits, comets get scattered throughout the inner solar system, and the delicate gravitational balance that keeps everything stable gets temporarily disrupted. We might be witnessing the early stages of such a reorganization right now. Some of the unusual orbital patterns we observe in the outer solar system might be harbingers of changes that will reshape our cosmic neighborhood over the next 100 million years. But here's the truly sobering part. These reorganizations don't just move rocks around. They can dramatically affect the habitability of planets. If Earth's orbit were to shift by just a few %, it could trigger ice ages or runaway greenhouse effects that would make our planet uninhabitable. The solar system you learned about in school was a snapshot, a single frame from a movie that's been playing for billions of years and will continue playing for billions more. We happen to be living during a relatively stable period, but that stability isn't permanent. It's not guaranteed. It's a temporary arrangement in a cosmic dance that's constantly evolving. Speaking of evolution, let me tell you about one of the most remarkable discoveries in recent planetary science. We've found that planets can fundamentally change their nature over time. They can transform from one type of world into something completely different. Take Venus, our so-called sister planet. Today, Venus is a hellish world with surface temperatures hot enough to melt lead and atmospheric pressure 90 times greater than Earth's. The atmosphere is made almost entirely of carbon dioxide, with clouds of sulfuric acid that rain down on the surface. But Venus wasn't always like this. Early in its history, Venus might have been remarkably similar to Earth. It might have had liquid water oceans, a moderate climate, and atmospheric conditions that could have supported life. Computer models suggest that Venus remained habitable for possibly 2 billion years after its formation. So what happened? What transformed our sister world from a potential paradise into the toxic furnace we see today? The answer lies in a process called the runaway greenhouse effect. As Venus received more solar energy than Earth due to its closer proximity to the Sun, water began evaporating from its oceans. Water vapor is a greenhouse gas, so this caused temperatures to rise, which caused more water to evaporate, which caused temperatures to rise even more. Eventually, Venus reached a tipping point where all of its water vapor was lost to space, leaving behind a dense atmosphere of carbon dioxide that trapped heat so efficiently that the planet's surface became hot enough to glow like a coal. But here's the terrifying implication. Earth could undergo the same transformation. As our sun gradually becomes brighter over the next billion years, Earth will receive more and more solar energy. Eventually, possibly sooner than we think, our planet could reach the same tipping point that transformed Venus. This isn't science fiction. This isn't speculation. This is thermodynamics. This is the inevitable fate of any planet that orbits too close to an aging star. The only question is when it will happen, and whether life on Earth will find a way to prevent or adapt to this transformation. But let's journey to an even more mysterious realm of our solar system. A place so remote, so poorly understood, that it challenges our basic assumptions about what exists in the space between stars. I'm talking about the heliopause, the boundary where our sun's influence ends and interstellar space begins. For decades, scientists thought this boundary would be relatively simple, a gradual transition from the solar wind to the interstellar medium. But when our Voyager spacecraft finally reached this region, they discovered something completely unexpected. The heliopause isn't a smooth boundary. It's a complex, dynamic region filled with structures and phenomena that we never predicted. There are magnetic highways that channel cosmic rays in unexpected directions. There are pockets of heated plasma that shouldn't exist according to our models. There are waves and instabilities that suggest the boundary between our solar system and interstellar space is far more active and complex than anyone imagined. Even more intriguing, Voyager has detected sounds in interstellar space, not sounds in the traditional sense, since sound can't travel through a vacuum, but electromagnetic oscillations that can be converted into audio frequencies. These cosmic sounds reveal that interstellar space isn't the empty void we once thought it was. It's filled with structure, with activity, with phenomena that we're only beginning to understand. The data from Voyager suggests that our solar system exists within what scientists call the local interstellar cloud, a region of space with its own unique properties and characteristics. We're not just floating in empty space, we're embedded within a cosmic structure that extends far beyond our solar system and influences everything within it. This discovery has profound implications for our understanding of how solar systems form and evolve. It suggests that the interstellar environment plays a much more active role in planetary science than we ever realized. The properties of the space between stars might determine which types of solar systems can form and which types of planets can develop within them. Now let me share with you perhaps the most mind-bending aspect of our solar system's hidden nature. Something that reveals just how interconnected and dynamic our cosmic neighborhood really is. Our solar system isn't just a collection of objects orbiting the sun. It's a single, integrated system where everything influences everything else in ways both obvious and subtle. The gravitational field of Jupiter affects the orbit of every asteroid in the belt. The magnetic field of Saturn shapes the behavior of cosmic rays throughout the outer solar system. The solar wind carries particles and energy to the farthest reaches of our cosmic domain. But the connections go even deeper than that. The very elements that make up our bodies, the carbon and oxygen and iron that flow through our veins, were created in the nuclear furnaces of stars that exploded billions of years ago. We're not just living in the solar system. We're made from the solar system. We're arrangements of stellar material that have become conscious and are now trying to understand their own cosmic origins. Every breath you take contains atoms that were once part of distant stars. Every thought in your mind depends on electrical impulses carried by elements that were forged in supernova explosions. You're not separate from the cosmos. You're part of it. You're a way for the universe to know itself. This perspective transforms everything. It means that when we study the solar system, we're not just learning about distant worlds and abstract physics. We're learning about ourselves. We're discovering the cosmic processes that made our existence possible. The water in your body has been cycling through the solar system for billions of years. It might have once existed in the primordial solar nebula, then in comets that bombarded the early Earth, then in ancient oceans, then in clouds, then in rain, and now it's part of you. You're carrying within yourself the history of our entire solar system. The calcium in your bones was created in the dying moments of massive stars. The iron in your blood was forged in stellar cores under temperatures and pressures that dwarf anything we can create on Earth. You're literally made of stardust, and that's not poetry. That's physics. But perhaps the most profound realization is this. If the solar system is so much stranger and more wonderful than we ever imagined, what does that tell us about the rest of the universe? If our own cosmic neighborhood contains moons with hidden oceans, planets where diamonds rain from the sky, and gravitational phenomena that can reshape entire regions of space, what wonders await us in the vast expanse beyond our solar system? We're living in a universe where planets migrate like cosmic nomads, where moons harbor alien seas, where the very definition of what makes a world is constantly being rewritten by new discoveries. And we've only just begun to explore our own small corner of this cosmic ocean. Every year, our robots and telescopes reveal new mysteries, new wonders, new questions that force us to reconsider everything we thought we knew. The solar system isn't just stranger than we imagine. It's stranger than we can imagine, at least with our current understanding. As we drift deeper into this cosmic meditation, remember that you're not just learning about distant worlds. You're discovering the true nature of your cosmic home. You're uncovering the hidden connections that link every atom in your body to every star in the sky. The solar system they didn't teach you in school isn't just a collection of facts to memorize. It's a revelation of the profound interconnectedness of all things. A glimpse into the elegant complexity that underlies the apparent simplicity of our cosmic neighborhood. And there's so much more waiting to be discovered. So many secrets still hidden in the data streaming back from our spacecraft. So many mysteries lurking in the shadows of distant worlds. So many questions that will reshape our understanding of what it means to exist in this strange and wonderful universe we call home. But let me take you on a journey to perhaps the most mind-bending revelation about our solar system. Something so counterintuitive, so fundamentally different from what you learned, that it will change how you see every sunrise for the rest of your life. The sun isn't yellow, it never was. That friendly golden orb you've been drawing with crayons since kindergarten, that warm yellow disk that seems to paint everything in honey-colored light. It's an illusion, a trick of perception created by our atmosphere. In space, where there's no air to scatter and filter light, our sun appears brilliant white. Pure, blazing white. The yellow color you see is caused by Earth's atmosphere preferentially scattering blue light, leaving the warmer colors to reach your eyes. But that's not even the strangest part. The sun you see in the sky isn't really the sun as it exists right now. It's the sun as it was 8 minutes and 20 seconds ago. Light, even though it travels at the fastest speed possible in our universe, still takes time to cross the vast gulf between our star and our planet. You're literally looking into the past every time you glance at the sky. But here's where it gets truly unsettling. The sun is constantly changing, constantly evolving, constantly becoming something different than it was. Those 8 minutes represent a gap in time during which anything could have happened to our star. It could have suddenly brightened, dimmed, or even exploded, and we wouldn't know until the light carrying that information finally reached us. This delay isn't just an academic curiosity, it's a fundamental feature of reality that affects everything in our solar system. When you look at Jupiter, you're seeing it as it was between 33 and 54 minutes ago, depending on where Earth and Jupiter happen to be in their orbits. When you observe Saturn, you're looking over an hour into the past. The solar system you think you're observing doesn't actually exist. It's a collection of historical images, light-speed postcards from different moments in the past, all arriving at your eyes simultaneously to create the illusion of a present moment reality. Now, let me shatter another fundamental assumption about our cosmic home. Remember how they taught you that space is empty, that the vast distances between planets are just vacuum, just nothingness waiting to be crossed. Space isn't empty. It's never been empty. It's filled with an invisible ocean of particles and fields that connects every world in our solar system. The solar wind, a stream of charged particles flowing outward from our sun, creates a magnetic bubble around our entire solar system called the heliosphere. We're all swimming in this stellar atmosphere, this extended embrace of our star that reaches far beyond the orbit of Pluto. But the solar wind isn't just empty space filled with particles. It's a dynamic, ever-changing medium that carries information, energy, and influence throughout our cosmic neighborhood. When a solar flare erupts on the sun's surface, that disturbance ripples outward through the solar wind like a stone thrown into a cosmic pond. Days later, those ripples reach Earth, causing aurora to dance in our polar skies and sometimes disrupting our satellites and power grids. This means that everything in our solar system is connected in real time through this invisible medium. Mars experiences the same solar storms that affect Earth. Jupiter's massive magnetosphere interacts with the solar wind to create radio emissions that we can detect from Earth. Even distant Pluto feels the influence of our sun through this stellar atmosphere. But here's something even more remarkable. Our solar system is constantly exchanging material with the rest of the galaxy. Cosmic rays, high-energy particles from distant stars and exotic cosmic events rain down on every world in our solar system. These particles carry with them the signatures of stellar explosions, black hole accretion disks, and other violent events occurring thousands of light years away. In a very real sense, our solar system is permeable. It's not a closed system isolated from the rest of the universe. It's constantly breathing in cosmic material and breathing out solar wind, participating in a galactic circulation that connects us to the most distant reaches of our galaxy. Some of these cosmic rays have been traveling for millions of years before reaching our solar system. They carry with them information about cosmic events that occurred when our planet was a very different place, when different species dominated Earth, when continents were arranged in unfamiliar patterns. Every second, thousands of these cosmic messengers pass through your body, carrying stories of stellar deaths and cosmic violence from across the galaxy. You're not just made of solar system material. You're constantly being bathed in particles that have witnessed the birth and death of stars, the collision of galaxies, the formation of black holes. But let's venture into an even more unsettling realm of solar system science. Something that challenges our basic understanding of planetary formation and the stability of orbital mechanics. Our solar system contains rogue objects, worlds that don't belong to any star, planets that wander through interstellar space in eternal darkness. These aren't science fiction concepts. They're real, and some of them might occasionally pass through our solar system. Recent astronomical surveys have discovered what appear to be planet-sized objects drifting through interstellar space, too far from any star to be gravitationally bound, too large to be ordinary asteroids or comets. These rogue planets were either ejected from their birth solar systems by gravitational interactions, or formed in isolation in the cold depths of space. Computer models suggest that rogue planets might actually outnumber stars in our galaxy. There could be billions, possibly trillions of these dark wandering worlds drifting through the cosmic void. Some might be frozen Earth-like worlds, their atmospheres collapsed into snow on their surfaces. Others might be massive gas giants, still glowing with the heat of their formation. Miniature failed stars wandering eternally through the darkness. But here's what keeps astronomers awake at night. Some of these rogue planets might pass close enough to our solar system to gravitationally disrupt the orbits of our planets. A close encounter with a rogue Jupiter-sized world could potentially eject Earth from the solar system, sending our planet tumbling into the cosmic deep. This isn't just theoretical speculation. We've observed rogue planets in our cosmic neighborhood. Objects like WISE J0830 Plon2 837, a world roughly 12 times more massive than Jupiter, drifting through space only about 7 light-years from our solar system. It's moving through space at over 200,000 miles per hour, a cosmic bullet that could fundamentally alter the gravitational architecture of any solar system it encounters. The implications are staggering. The stability of our solar system, the predictable orbits that allow us to plan space missions decades in advance, might be temporary conditions. We exist during a period of relative gravitational calm, but that calm could be shattered by the arrival of a rogue planet we haven't even detected yet. Now, let me reveal something about planetary formation that will completely rewrite your understanding of how worlds come to exist. The traditional model taught in schools suggests that planets form through a gradual process of accretion, with dust particles slowly sticking together to form larger and larger objects until they become planets. But recent discoveries have revealed that planet formation is far more violent, far more chaotic than we ever imagined. Planets don't just grow slowly and steadily. They form through catastrophic collisions between objects the size of moons and small planets. These impacts are so energetic that they literally melt entire worlds, creating massive magma oceans that take millions of years to cool and solidify. The evidence for this violent birth process is written in the very rocks beneath your feet. The Moon, as I mentioned earlier, formed from the debris of a Mars-sized impact with Earth, but similar collisions shaped every planet in our solar system. Venus rotates backward because it was likely struck by a massive object that reversed its spin. Uranus rotates on its side because it suffered an impact so severe that it knocked the planet over completely. These weren't gentle, gradual processes. These were cosmic catastrophes that would have made the planet uninhabitable for millions of years at a time. Earth has been completely molten multiple times in its history, its surface glowing like a coal in the cosmic darkness, while debris from massive impacts rained down like hellfire. But here's the most remarkable part. Life survived these catastrophes. Somehow, despite impacts that vaporized oceans and melted continents, biological processes found ways to persist, to adapt, to eventually flourish again when conditions stabilized. This resilience of life has profound implications for our understanding of habitability throughout the solar system. If life can survive the kind of cosmic violence that shaped the planets, then it might be far more common, far more tenacious than we ever imagined. But let's explore something even more fundamental about our solar system's hidden nature. Something that reveals just how dynamic and ever-changing our cosmic neighborhood really is. The asteroid belt between Mars and Jupiter isn't what you think it is. In movies and popular culture, it's often portrayed as a dense field of tumbling rocks that spaceships must carefully navigate to avoid collision. But the reality is far stranger and more subtle. The asteroid belt is mostly empty space. The asteroids are so widely scattered that if you were flying a spacecraft through the belt, you would be lucky to see even one asteroid with the naked eye. The total mass of all the asteroids combined is less than 4% of our Moon's mass. It's not a barrier. It's barely even a presence. But what makes the asteroid belt truly fascinating isn't what's there now. It's what should be there but isn't. Computer models of early solar system formation predict that there should be a planet between Mars and Jupiter. The material was there. The gravitational conditions were right. A world should have formed, but it didn't. Instead, Jupiter's massive gravitational influence prevented the material from coalescing into a planet. The gas giant's gravity stirred up the region so violently that instead of accreting into a single world, the material remained scattered in thousands of separate chunks. In other words, the asteroid belt is the graveyard of a planet that never was. It's a cosmic what if, a reminder of how different our solar system could have been if Jupiter had formed elsewhere or hadn't grown so massive so quickly. But some of the asteroids in this failed planet zone hold secrets that are even more remarkable than their origin story. Ceres, the largest object in the asteroid belt and now classified as a dwarf planet, contains more fresh water than exists on Earth. Not ice. Liquid water, possibly in vast underground oceans, kept warm by radioactive decay and tidal heating. Recent observations have revealed bright spots on Ceres's surface that appear to be salt deposits left behind by water that erupted from the interior and then evaporated in the vacuum of space. This suggests that Ceres is geologically active, that it has water cycles, that it might even have the conditions necessary for primitive life. Think about that for a moment. There might be alien microorganisms living in underground oceans in the asteroid belt, in what was supposed to be the empty space between Mars and Jupiter. Life might exist in places so unexpected, so overlooked, that we're only now beginning to consider them as potential habitats. But Ceres isn't the only asteroid harboring secrets. Vesta, the second largest asteroid, shows evidence of having once been partially molten, with different types of rock that could only have formed in the presence of liquid magma. Some meteorites found on Earth appear to have originated from Vesta, blasted off its surface by impacts and eventually finding their way to our planet. This means that pieces of the asteroid belt are constantly raining down on Earth. Right now, as you're listening to these words, fragments of Vesta, pieces of other asteroids, and possibly even material from comets are burning up in our atmosphere as shooting stars. You might have walked past a meteorite from the asteroid belt without even knowing it. The boundary between Earth and the rest of the solar system isn't as clear as you might think. We're constantly exchanging material with other worlds, participating in a cosmic circulation that has been going on for billions of years. Now let me take you to the most mysterious region of our solar system, a place so remote, so poorly understood, that everything we think we know about it might be wrong. Beyond the orbit of Neptune, in the frozen reaches of the outer solar system, lies a region called the scattered disk. This is where the most eccentric, most unpredictable objects in our solar system reside. These are worlds with orbits so elongated, so tilted, that they spend most of their time in the cosmic deep, far from the warmth and light of our sun. Eris, one of the largest known dwarf planets, follows an orbit so eccentric that its distance from the Sun varies by billions of miles. At its closest approach, it's roughly the same distance from the Sun as Pluto. At its farthest point, it's 3 times farther away than Pluto, wandering in regions of space so cold and dark that the Sun appears as nothing more than a bright star. But Eris isn't alone in its cosmic exile. There are dozens of known objects in the scattered disk, and probably thousands more waiting to be discovered. These are worlds that exist at the very edge of our solar system's gravitational influence. Cosmic hermits that spend centuries in the darkness before making brief appearances in the inner solar system. Some of these objects have orbital periods measured in thousands of years. A world like Sedna, another dwarf planet in the outer reaches, takes over 11,000 years to complete one orbit around the Sun. When Sedna was last at its closest approach to the Sun, human civilization was just beginning to develop agriculture. The next time it returns to this position, our entire technological civilization might be nothing but archaeological curiosities. But here's what makes these distant worlds truly unsettling. Their orbits don't make sense according to our current understanding of solar system formation. They're too distant, too eccentric, too tilted to have formed where they are now. Something must have scattered them into these extreme orbits, but we don't know what. Some scientists believe these objects are evidence of gravitational interactions with passing stars that came close to our solar system billions of years ago. Others think they might be the scattered remnants of a much larger population of objects that once existed in the outer solar system, but were disrupted by some unknown catastrophe. But the most intriguing possibility is that these objects are telling us about the existence of undiscovered worlds in our solar system. Their strange orbital patterns might be the gravitational signatures of massive planets lurking in the cosmic darkness, worlds so distant and so faint that our telescopes haven't detected them yet. The search for these hypothetical worlds has become one of the most exciting frontiers in planetary science. Every year, astronomers discover new objects in the outer solar system, and each discovery adds new pieces to a puzzle that we're only beginning to understand. But perhaps the most profound implication of these discoveries is what they tell us about the nature of exploration itself. Despite centuries of astronomical observation, despite space probes that have visited every planet in our solar system, we're still discovering new worlds in our own cosmic backyard. The solar system isn't a completed map with every feature charted and catalogued. It's a frontier that's constantly revealing new territories, new mysteries, new questions that challenge our understanding of how planetary systems form and evolve. As we drift deeper into this cosmic contemplation, remember that every fact I've shared represents not just new information, but a fundamental shift in perspective. The solar system isn't a static collection of objects frozen in time and space. It's a dynamic, evolving system where new discoveries constantly reshape our understanding of what's possible. You're living during one of the most exciting periods in the history of planetary science. Right now, as you're listening to these words, robotic explorers are beaming back data from across the solar system. Telescopes are discovering new worlds in the outer darkness. Computer models are revealing new possibilities for where life might exist. The solar system they didn't teach you in school isn't just more complex than the simplified version you learned as a child. It's more beautiful, more mysterious, more alive with possibility than anyone imagined just a few decades ago. And we've only scratched the surface. There are moons we haven't visited, regions we haven't explored, phenomena we haven't discovered. The greatest revelations about our cosmic home might still be waiting for us in the data streaming back from distant spacecraft, in the observations of next-generation telescopes, in the minds of future scientists who will ask questions we haven't even thought to pose. Every sunrise you witness, every time you look up at the night sky, you're seeing the result of cosmic processes so ancient, so complex, so beautiful, that they connect you to the deepest mysteries of existence itself. You're not just an observer of the solar system, you're part of it, made from it, inseparably connected to its ongoing story of discovery and wonder. The most haunting discovery about our solar system happened when we started listening to the sounds of space itself. And yes, space does make sounds. Not the Hollywood explosions and roaring engines you might expect, but something far more eerie and profound. When our Voyager spacecraft crossed into interstellar space, its instruments detected electromagnetic oscillations that can be converted into audio. These cosmic whispers reveal that the space between worlds isn't the silent void we imagined. It's alive with electromagnetic activity, with plasma waves that ripple through the solar wind like songs sung by invisible choirs. Jupiter generates radio emissions so powerful they can be picked up by amateur radio operators on Earth. These aren't random static. They're complex, structured signals that change in response to the positions of Jupiter's moons, particularly Io. It's as if the gas giant is broadcasting a cosmic radio show, with its volcanic moon serving as the announcer. Saturn's rings sing too. The Cassini spacecraft recorded electromagnetic emissions from Saturn's ring system that sound eerily like whale songs when converted to audio frequencies. These sounds are generated by the interaction between charged particles and the countless ice chunks that make up the rings, creating a symphony that has been playing in the darkness for millions of years. But perhaps the most unsettling sounds come from our own planet's magnetosphere. When the solar wind interacts with Earth's magnetic field, it creates what scientists call chorus waves. These electromagnetic oscillations, when converted to audio, sound like birds chirping in space, invisible choirs of electromagnetic energy singing around our planet every single day. This acoustic dimension of our solar system was completely unknown until just a few decades ago. For all of human history, we assumed space was silent. But it turns out that every world, every moon, Every magnetic field is constantly generating its own unique electromagnetic signature, its own cosmic voice. Now let me tell you about something that will fundamentally change how you think about the emptiness between planets. That vast space isn't empty at all. It's filled with something called the zodiacal light, a faint glow that extends throughout the inner solar system like a cosmic fog. This isn't some exotic phenomenon. This is sunlight reflecting off countless particles of dust, most of them smaller than the finest flower, that orbit the sun in a vast disk. These particles are the debris of comet tails, the remnants of asteroid collisions, the cosmic dust that has been accumulating for billions of years. On a clear, dark night, far from city lights, you can actually see this zodiacal light with your naked eye. It appears as a faint, triangular glow extending up from the horizon after sunset or before sunrise. You're seeing the architecture of our solar system made visible, the hidden medium through which all the planets move. But this cosmic dust does more than just create pretty glows in the sky. It affects the orbits of spacecraft, creating tiny but measurable drag forces that mission planners must account for. It influences the behavior of solar wind particles. It even affects the temperature of planets by scattering and absorbing sunlight in ways that vary depending on each world's orbital position. Every breath you take on Earth contains some of this cosmic dust. Particles from asteroids and comets constantly rain down on our planet, adding about 40 tons of extraterrestrial material to Earth every single day. You're breathing stardust. You're inhaling the solar system. But let's venture into something even more mind-bending. The discovery that our solar system contains structures that shouldn't exist according to our understanding of physics. I'm talking about the Pioneer anomaly, a mystery that puzzled scientists for decades and revealed just how much we still don't know about the fundamental forces operating in our cosmic neighborhood. The Pioneer 10 and 11 spacecraft, launched in the 1970s to explore the outer solar system, began behaving strangely as they traveled beyond the orbit of Neptune. Instead of following the precise trajectories predicted by our understanding of gravity, they were slowing down by a tiny but measurable amount. This wasn't instrument error. This wasn't a malfunction. The spacecraft were experiencing a real physical force that was acting contrary to everything we knew about how gravity works in the outer solar system. For years, scientists proposed exotic explanations. Maybe there was an unknown form of matter in the outer solar system. Maybe our understanding of gravity itself was incomplete. The mystery was eventually solved, but the solution was almost as unsettling as the mystery itself. The anomaly was caused by heat radiating from the spacecraft's own nuclear power sources, creating a tiny but persistent thrust that accumulated over the decades-long journey. But here's what's truly remarkable about this discovery. It revealed that even our most sophisticated models of spacecraft behavior, our most precise calculations of orbital mechanics, can be wrong in ways we don't anticipate. If we can be surprised by the behavior of spacecraft we built and launched ourselves, what does that tell us about phenomena occurring in regions of the solar system we've never visited? What forces might be operating in the outer darkness that we haven't even imagined yet? This humbling realization extends to our understanding of planetary formation itself. Recent computer simulations have revealed that the process by which worlds come into existence is far more chaotic and unpredictable than the orderly accretion model taught in textbooks. Planets don't just grow slowly and steadily from cosmic dust. They form through violent collisions between objects called planetesimals, mountain-sized chunks of rock and ice that smash into each other at speeds of thousands of miles per hour. These impacts are so energetic that they can completely vaporize both objects, creating clouds of molten debris that eventually recondense into new, larger bodies. But here's where it gets truly strange. Sometimes these collisions don't result in larger planets. Sometimes they result in the complete destruction of both objects, scattering their material throughout space. Computer models suggest that for every planet that successfully forms, dozens of potential worlds are destroyed in failed collision events. This means that planetary formation isn't just a creative process, it's also a destructive one. Our solar system is littered with the debris of worlds that almost were, planets that came close to forming but were shattered by cosmic violence before they could achieve stability. Some of the asteroids in our solar system might be the fragments of these failed worlds. Some of the comets in the outer solar system might be carrying the water and organic compounds that would have become the building blocks of life on planets that never had the chance to exist. Every world in our solar system, including Earth, is a survivor of this cosmic demolition derby. We exist not just because conditions were right for planetary formation, but because we managed to avoid the countless catastrophes that destroyed so many other potential worlds. But survival in the early solar system required more than just avoiding destructive collisions. It required navigating a period of cosmic chaos so extreme that it nearly sterilized every world that had managed to form. This period, called the Late Heavy Bombardment, occurred roughly 4 billion years ago, when the migration of the giant planets sent billions of asteroids and comets careening through the inner solar system. For several 100 million years, every solid surface in our cosmic neighborhood was subjected to a relentless barrage of impacts. The evidence for this bombardment is still visible today. The Moon's heavily cratered surface, Mercury's battered landscape, the ancient impact basins on Mars. They're all testimony to a time when space was filled with cosmic bullets, when impacts large enough to boil oceans and vaporize atmospheres occurred every few million years. Earth suffered through this bombardment too, but unlike the Moon and other airless worlds, our planet's active geology has erased most of the evidence. The craters have been filled in by volcanic activity, worn away by erosion, covered by billions of years of geological processes. But some evidence remains. Deep in Earth's ancient rocks, scientists have found traces of unusual elements that can only be explained by massive asteroid impacts. Layers of shocked quartz that form only under the extreme pressures generated by cosmic collisions. Deposits of rare metals that are common in asteroids but shouldn't exist in Earth's crust. These geological fingerprints tell a story of a planet under siege, a world that was repeatedly struck by objects large enough to fundamentally alter its surface and atmosphere. And yet, somehow, life survived. Somehow, in the midst of this cosmic violence, biological processes found ways to persist, to adapt, to eventually flourish. This resilience of early life has profound implications for our understanding of habitability throughout the universe. If life can survive the kind of bombardment that our planet experienced, then it might be far more tenacious, far more adaptable than we ever imagined. But the Late Heavy Bombardment wasn't just a period of destruction. It was also a period of delivery. Many of the impacting objects were comets and asteroids rich in water and organic compounds. These cosmic deliveries might have provided Earth with much of its water and the chemical building blocks necessary for life. In other words, the same bombardment that nearly sterilized our planet might also have provided the ingredients that made complex life possible. This paradox, this delicate balance between destruction and creation, appears to be a fundamental characteristic of planetary evolution throughout our solar system. Now, let me take you to a discovery so recent, so revolutionary, that it's still reshaping our understanding of what's possible in planetary science. We've found that some moons in our solar system are more active, more dynamic, more alive than most planets. Enceladus, Saturn's sixth largest moon, appeared unremarkable until the Cassini spacecraft discovered something extraordinary. This small, icy world is shooting massive geysers of water and organic compounds into space through cracks in its south polar region. These aren't small leaks. These are powerful eruptions that launch material hundreds of miles above the moon's surface. But the truly remarkable discovery came when Cassini flew through these geysers and analyzed their composition. The water isn't just pure H2O. It contains complex organic molecules, dissolved salts, and other compounds that suggest a rich, chemically active environment beneath Enceladus's frozen surface. Computer models indicate that Enceladus harbors a global ocean beneath its icy crust, an alien sea that contains more water than Lake Superior. This ocean is kept liquid by tidal heating, the same gravitational forces that power Io's volcanic fury. But unlike Io's hellish landscape, Enceladus's hidden ocean might be one of the most promising places to search for life in our solar system. The geysers are essentially providing us with free samples of this alien ocean. Every eruption launches into space material that has been in contact with Enceladus's rocky core, where hydrothermal processes might be occurring similar to those that support life around deep-sea vents on Earth. But Enceladus isn't the only moon harboring hidden seas. Europa, Ganymede, Callisto, Titan, and possibly several other moons throughout the outer solar system appear to have subsurface oceans. This means that liquid water, the fundamental requirement for life as we know it, might be far more common in our solar system than we ever imagined. These discoveries have completely revolutionized our understanding of habitability. For decades, scientists focused on the concept of the habitable zone, the narrow region around a star where temperatures are right for liquid water to exist on a planet's surface. But it turns out that some of the most promising habitats in our solar system exist on moons that are far outside this traditional habitable zone. The implications extend far beyond our own cosmic neighborhood. If moons can harbor oceans and potentially life even in the outer reaches of our solar system, then habitable environments might exist around countless stars throughout the galaxy, in places we never thought to look. But perhaps the most profound discovery about our solar system's hidden nature is something that challenges our basic understanding of planetary identity itself. We've learned that worlds can fundamentally transform their character over time, becoming something completely different than what they were. Mars, that cold, dry desert world you see in the night sky, wasn't always the frozen wasteland it appears to be today. Billions of years ago, Mars had a thick atmosphere, a robust magnetic field, and liquid water flowing across its surface. It might have been more Earth-like than any other planet in our solar system. But something catastrophic happened to Mars. Its magnetic field weakened and eventually disappeared, allowing the solar wind to gradually strip away its atmosphere. Without atmospheric protection, the liquid water on its surface boiled away into space or froze in underground reservoirs. The transformation of Mars from a potentially habitable world to the frozen desert we see today represents one of the most dramatic planetary changes in our solar system's history. And it raises a terrifying question. Could the same thing happen to Earth? Our planet's magnetic field isn't constant. It varies in strength over geological time, and it occasionally reverses completely, with magnetic north becoming magnetic south. During these reversal periods, which can last thousands of years, Earth's magnetic protection is significantly weakened. Computer models suggest that during magnetic reversals, our planet becomes more vulnerable to the same atmospheric stripping that transformed Mars. While Earth's stronger gravity and more robust atmosphere provide better protection than Mars had, the possibility of gradual atmospheric loss remains a long-term concern for our planet's habitability. But Mars holds secrets that extend far beyond its atmospheric history. Recent discoveries have revealed that the red planet is still geologically active in ways that nobody expected. Mars experiences what scientists call Mars quakes, seismic activity that indicates the planet's interior is still dynamic and evolving. Even more intriguingly, Mars appears to have seasonal cycles of methane release. Methane is a gas that breaks down quickly in the Martian atmosphere, so its presence indicates active, ongoing processes. These could be geological, involving interactions between rock and water in the planet's subsurface, or they could be biological, the result of microbial life that has survived in underground refugia since Mars's more hospitable past. The possibility that life might still exist on Mars, hidden in subsurface environments protected from the harsh surface conditions, represents one of the most exciting frontiers in astrobiology. We might not be alone in our solar system. There might be alien microorganisms living beneath our feet on a neighboring world, descendants of life forms that evolved when Mars was young and warm and wet. This prospect has transformed Mars from a dead world into one of the most intriguing targets for future exploration. Every mission to Mars now carries instruments designed to search for signs of past or present life, making each new discovery a potential answer to one of humanity's most profound questions. As we near the end of our journey through the hidden truths of our solar system, remember that every revelation I've shared represents just the beginning of our understanding. Each discovery opens new questions, reveals new mysteries, points toward phenomena we haven't even begun to investigate. The solar system isn't a completed story with all the chapters written and all the secrets revealed. It's an ongoing narrative of discovery, where every new observation has the potential to revolutionize our understanding of how planetary systems work, how life emerges and evolves, and what possibilities exist for worlds beyond our own. You're living during a golden age of solar system exploration. Right now, as you're contemplating these cosmic truths, robotic emissaries are exploring worlds throughout our cosmic neighborhood. Rovers are analyzing rocks on Mars. Orbiters are mapping the surfaces of distant moons. Spacecraft are flying through the plumes of icy geysers, tasting alien oceans and searching for signs of life. The next great discovery about our solar system could happen tomorrow. It could be hiding in data that's already been collected, but not yet analyzed. It could be waiting in the shadows of a distant moon, in the chemistry of a comet's tail, in the magnetic field patterns of a planet we thought we understood. But perhaps the most remarkable thing about all these discoveries is what they reveal about the nature of existence itself. We live in a universe where worlds can harbor hidden oceans, where diamonds rain from alien skies, where the very definition of what makes a planet continues to evolve with each new observation. Every atom in your body participated in this cosmic story. The hydrogen in your cells was forged in the first moments after the Big Bang. The heavier elements were created in the nuclear furnaces of stars that lived and died billions of years ago. The water in your blood has been cycling through the solar system since before Earth existed, traveling from comet to ocean to cloud to rain to you. You're not separate from this cosmic narrative. You're part of it. You're a temporary arrangement of stellar material that has become conscious enough to contemplate its own origins, to wonder about its place in the universe, to ask questions about the nature of existence itself. The solar system they didn't teach you in school isn't just a collection of facts to memorize or phenomena to catalogue. It's a revelation of the profound interconnectedness of all things, a glimpse into the elegant complexity that underlies the apparent simplicity of our cosmic home. And there's so much more waiting to be discovered. So many worlds still to explore. So many questions still to answer. So many mysteries still hidden in the darkness between the stars. The greatest revelations about our solar system might still be ahead of us, waiting for the next generation of explorers to ask questions we haven't even thought to pose. As we drift deeper into the most profound mysteries of our cosmic home, let me share something with you that will fundamentally alter how you perceive the very concept of planetary weather. When you think of weather, you probably imagine rain, snow, wind, the familiar patterns that shape our daily lives on Earth. But the weather systems operating throughout our solar system are so alien, so utterly beyond anything in terrestrial experience that they challenge our basic understanding of what atmospheric phenomena can become. On Venus, it doesn't just rain. It rains sulfuric acid from clouds that tower 40 miles above the surface. But this acid rain never reaches the ground. The temperatures are so extreme that the droplets evaporate completely before they can fall more than a few miles, creating what scientists call virga, phantom precipitation, that exists only in the upper atmosphere. Imagine sheets of acid rain falling through alien skies, dissolving into mist before touching a surface hot enough to melt lead. But Venus holds an even stranger atmospheric secret. The entire planet experiences something called superrotation, where the atmosphere spins around the world faster than the planet itself rotates. Venus takes 243 Earth days to complete one rotation, but its atmosphere circles the planet in just 4 days. This creates winds that reach speeds of over 200 miles per hour in the upper atmosphere, while the surface remains eerily calm. Think about the physics required to maintain such a phenomenon. The atmosphere of an entire world spinning independently of the solid planet beneath it, driven by mechanisms so complex that atmospheric scientists are still struggling to understand them. It's as if Earth's entire atmosphere decided to race around our planet at hurricane speeds, while the surface remained perfectly still. Now let me take you to Titan, where the weather systems are so bizarre they seem designed by an alien intelligence with a completely different understanding of chemistry. On this moon of Saturn, it rains liquid methane from clouds made of hydrocarbons. These aren't brief showers. These are seasonal deluges that can last for weeks, filling vast lakes with liquid natural gas under skies the color of burnt orange. The methane cycle on Titan mirrors Earth's water cycle in ways that are both familiar and deeply unsettling. Liquid methane evaporates from the surface, rises through the atmosphere, condenses into clouds, and falls again as rain. But this is methane we're talking about. The same gas that burns in your stove, falling like water from alien skies, and pooling in lakes that could fuel human civilization for millennia. These methane lakes aren't small puddles. Some of them are larger than the Great Lakes, with depths that reach hundreds of feet. Kraken Mare, the largest known lake on Titan, is bigger than the Caspian Sea and contains more liquid hydrocarbons than all of Earth's oil reserves combined. It's an ocean of natural gas under alien skies, lapped by waves of liquid methane driven by winds that smell like the contents of a gas station. But perhaps the most mind-bending aspect of Titan's weather is what happens during its changing seasons. Titan's year lasts about 29 Earth years, and as the seasons progress, entire lake systems can evaporate and reform in different locations. Imagine if Lake Superior disappeared during winter and reappeared on the other side of the continent during summer, and you'll begin to understand the scale of atmospheric dynamics operating on this distant moon. The implications of these discoveries extend far beyond mere scientific curiosity. They reveal that the concept of habitability, of what conditions might support life, is far more flexible than we ever imagined. If complex atmospheric systems can operate using methane instead of water, what other forms of chemistry might support the emergence of life in environments we've never considered? But let's venture into something even more unsettling about our solar system's hidden nature. We've discovered that some worlds experience phenomena that exist at the very edge of what physics allows, conditions so extreme they border on the impossible. Deep within Jupiter's atmosphere, at pressures millions of times greater than Earth's surface, hydrogen behaves in ways that would have seemed like magic to scientists just a few decades ago. Under these crushing conditions, hydrogen becomes metallic, conducting electricity like copper wire while remaining fluid like water. This metallic hydrogen ocean might extend for thousands of miles through Jupiter's interior, creating the most powerful magnetic field in our solar system. But that's not the strangest part. Some theoretical models suggest that within this metallic hydrogen ocean, conditions might exist where hydrogen molecules are compressed so severely that they break apart and reform into structures that don't exist anywhere else in the universe. We're talking about phases of matter so exotic that they can only be studied through computer simulations and theoretical physics. The energy contained within Jupiter's metallic hydrogen core is almost incomprehensible. If we could somehow extract just 1% of this energy, it would power human civilization at current consumption levels for millions of years. Yet this incredible energy source exists within a ball of gas that we can see with the naked eye on any clear night. This revelation about Jupiter's interior has forced scientists to reconsider everything they thought they knew about the internal structure of gas giant planets. Uranus and Neptune, those distant ice giants, might harbor their own exotic forms of matter. Computer models suggest that deep within Neptune's interior, the extreme pressure and temperature might create conditions where water, methane, and ammonia are compressed into supersonic ice, a form of water where the hydrogen atoms behave like a liquid, while the oxygen atoms remain locked in a solid crystal structure. Imagine water that's simultaneously solid and liquid, ice that conducts electricity like metal, chemical states that exist nowhere on Earth and push the boundaries of what we consider physically possible. These aren't science fiction concepts. These are the actual conditions existing right now within worlds we can observe through telescopes. But perhaps the most profound discovery about exotic matter in our solar system comes from recent studies of the space between planets themselves. What we once thought of as empty vacuum is actually filled with something far stranger than mere emptiness. The solar wind, that stream of charged particles flowing outward from our sun, doesn't travel through empty space. It moves through a medium filled with magnetic field lines, plasma waves, and structures so complex that they're only now being mapped by our most sophisticated spacecraft. This interplanetary medium has its own weather patterns, its own seasons, its own storms that can affect every world in our cosmic neighborhood. When a solar flare erupts on the sun's surface, it doesn't just send light and heat racing through space. It launches a shockwave through this interplanetary medium, a cosmic tsunami that ripples outward at millions of miles per hour. When these shockwaves reach Earth, they can disrupt satellite communications, damage power grids, and create aurora displays visible from the equator. But Earth isn't the only world affected by space weather. Mars, with its thin atmosphere and weak magnetic field, experiences dust storms that can engulf the entire planet when solar activity increases. These aren't ordinary dust storms driven by temperature differences. They're electrical phenomena where charged particles from the sun interact with dust in the Martian atmosphere to create planet-wide tempests that can last for months. Jupiter's magnetic field is so powerful that it traps charged particles from the solar wind, creating radiation belts that would be lethal to any unprotected spacecraft. The energy contained within these radiation belts is so intense that they generate radio waves powerful enough to detect from Earth using amateur radio equipment. Even distant Pluto, relegated to dwarf planet status but still harboring secrets, experiences its own form of space weather. As Pluto's elliptical orbit carries it closer to and farther from the Sun, its thin atmosphere expands and contracts dramatically. During its closest approach, nitrogen evaporates from the surface ice and creates a temporary atmosphere. During its farthest excursions, this atmosphere freezes and falls back to the surface as snow. This atmospheric breathing of Pluto occurs over a 248-year cycle, meaning that every location on the dwarf planet experiences both atmospheric and airless conditions over the course of its orbital period. Imagine living on a world where the air itself appears and disappears over timescales longer than human civilization has existed. But let me share with you something even more unsettling about the dynamic nature of our solar system. We've discovered that the orbits of planets aren't as stable and predictable as the diagrams in textbooks suggest. Over millions of years, gravitational interactions between planets can cause their orbits to shift in ways that fundamentally alter the architecture of our cosmic neighborhood. Computer simulations reveal that our solar system undergoes periodic episodes of orbital chaos, where the gravitational influence of the giant planets can cause dramatic changes in the orbits of smaller worlds. These episodes, occurring roughly every few million years, can send asteroids careening into the inner solar system, alter the tilt of planetary rotation axes, and even eject planets from the solar system entirely. We might be living during a period of relative stability that won't last forever. The intricate gravitational dance that keeps Earth in its comfortable orbit is more fragile than most people realize. A close encounter with a rogue planet, a slight change in Jupiter's orbit, or the gradual evolution of the Sun's mass could potentially destabilize our planet's orbital path over geological timescales. But perhaps most remarkably, we've discovered that our solar system is still growing, still evolving, still adding new members to its family of worlds. Every year, astronomers discover dozens of new objects in the outer solar system, some large enough to qualify as dwarf planets, others representing entirely new categories of celestial objects. These discoveries aren't just adding numbers to our catalogue of solar system objects. They're revealing that the outer reaches of our cosmic neighborhood are far more populous and diverse than anyone imagined. There might be hundreds of dwarf planets waiting to be discovered in the Kuiper Belt and scattered disk, each one potentially harboring its own unique characteristics and mysteries. Some of these newly discovered worlds challenge our basic understanding of what's possible in planetary science. Objects like Arakoth, visited by the New Horizons spacecraft, appear to be contact binaries, two separate objects that somehow came together and stuck, creating worlds with shapes that look like cosmic snowmen or peanuts. The discovery of these contact binaries has revolutionized our understanding of how small bodies in the outer solar system form and evolve. Rather than growing through violent collisions, these objects appear to have formed through gentle mergers, a process so delicate that it suggests the outer solar system was a much calmer environment during the early phases of planetary formation. But even more intriguing are the objects that don't fit into any existing category. Oumuamua, the first confirmed interstellar visitor to our solar system, exhibited characteristics that puzzled astronomers and forced them to reconsider their assumptions about what kinds of objects might be wandering between the stars. Oumuamua's elongated shape its unusual reflectivity, and its slight acceleration as it moved away from the Sun suggested properties unlike any asteroid or comet previously observed. Some scientists propose that it might be a fragment of a planet from another star system, while others suggested even more exotic possibilities. The discovery of Oumuamua revealed that our solar system is constantly being visited by objects from interstellar space, wandering fragments of other planetary systems that provide glimpses into how worlds form and evolve around different stars. We're not as isolated as we once thought. We're part of a galactic community where material is constantly being exchanged between star systems. But perhaps the most profound implication of all these discoveries is what they tell us about the nature of exploration itself. Despite decades of space missions, despite telescopes that can peer into the farthest reaches of the universe, we're still making fundamental discoveries about our own cosmic backyard. The solar system isn't a completed puzzle with all the pieces in place. It's a frontier that continues to reveal new territories, new phenomena, new questions that challenge our understanding of how planetary systems work. Every new mission, every new observation, every new analysis of existing data has the potential to revolutionize our understanding of our cosmic home. As you contemplate these revelations, remember that you're living during one of the most extraordinary periods in human history. For the first time, our species has developed the technology to explore other worlds directly, to send robotic emissaries throughout the solar system, to taste the atmospheres of alien worlds and sample the chemistry of distant moons. The data streaming back from these missions isn't just adding to our scientific knowledge, it's fundamentally changing how we understand our place in the universe. We're discovering that the cosmos is far stranger, far more dynamic, far more alive with possibility than our ancestors ever imagined. Every time you look up at the night sky, you're seeing the result of cosmic processes so ancient, so complex, so beautiful, that they connect you to mysteries that span billions of years. You're not just observing distant points of light, you're witnessing an ongoing story of discovery that began long before humans existed and will continue long after our species has vanished. The solar system they didn't teach you in school isn't just more complex than the simplified version you learned as a child. It's more wonderful, more mysterious, more alive with hidden secrets than anyone dared to imagine. And we've only just begun to read the first chapters of this cosmic story. But there's something even more profound waiting for us as we approach the culmination of our journey through these hidden truths. Something that will forever change how you understand your relationship to the cosmos itself. Because the greatest secret of our solar system isn't about distant worlds or exotic chemistry or strange orbital mechanics. The greatest secret is about you. You are, quite literally, the solar system becoming conscious of itself. Every atom in your body has a story that spans billions of years, a cosmic biography that connects you to the birth of stars, the death of worlds, and the endless dance of matter and energy that shapes our cosmic neighborhood. The calcium in your bones was forged in the nuclear furnace of a star that exploded before our sun even existed. That calcium traveled through interstellar space for millions of years as cosmic dust, eventually becoming part of the primordial cloud that collapsed to form our solar system. It condensed into rocky planetesimals, survived countless collisions, became part of early Earth's molten surface, dissolved in ancient oceans, and somehow found its way into the food chain that eventually led to you. Think about that journey. The very atoms that allow you to move, to think, to exist, are veterans of cosmic processes so violent and transformative that they dwarf anything in human experience. You're walking around with stellar remnants in your skeleton, carrying within yourself the nuclear legacy of dead stars. But the story goes deeper than that. The water in your cells has been cycling through our solar system since before Earth had continents. That water might have originated in comets from the outer reaches of our cosmic neighborhood, delivered to our young planet during the late heavy bombardment. It might have existed as ice on distant asteroids, as vapor in the atmospheres of alien worlds, as liquid in the hidden oceans of icy moons. Every molecule of water in your body has been on an epic journey through space and time. It has witnessed the formation of planets, the emergence of life, the rise and fall of countless species. It has fallen as rain on landscapes that no human eyes have ever seen, flowed in rivers on continents that existed before multicellular life evolved. The iron in your blood tells an even more dramatic story. Iron can only be created in the cores of massive stars, under temperatures and pressures so extreme that they exceed anything that exists in our solar system today. When those stars reached the end of their lives, they exploded in supernovae so violent that they briefly outshone entire galaxies. That iron in your bloodstream rode the shockwaves of stellar explosions across interstellar space, carrying with it the energy signature of one of the most powerful events in the universe. Every heartbeat that pumps blood through your veins is powered by atoms that were born in stellar violence billions of years ago. But here's what makes this story truly extraordinary. You're not just made from solar system material. You're currently participating in the ongoing evolution of our cosmic neighborhood. Every breath you take exchanges atoms with the atmosphere. Every meal you eat incorporates matter that has been cycling through Earth's biosphere for billions of years. Every time you exhale, you're returning atoms to the environment that will eventually become part of other organisms, other cycles, other stories. You're a temporary arrangement of cosmic matter that has achieved something unprecedented in the known universe. You've become aware. You can contemplate your own existence, wonder about your origins, ask questions about the nature of reality itself. You are, quite literally, the universe examining itself, stardust that has learned to think. This perspective transforms everything about how we understand our relationship to the cosmos. You're not a separate entity observing the solar system from the outside. You're part of it. You're a manifestation of the same processes that created planets and moons and asteroids. You're matter that has organized itself into complexity, atoms that have learned to wonder about their own cosmic heritage. When you look up at the stars, you're not just seeing distant suns, you're seeing your relatives, your cosmic family, the stellar furnaces that created the elements that make your existence possible. When you observe the planets through a telescope, you're not just studying alien worlds, you're examining different expressions of the same cosmic processes that shaped your own atomic structure. This realization carries with it a profound responsibility. You are consciousness emerging from the cosmos, awareness arising from matter, intelligence developing from the same materials that form asteroids and planets and stars. Your thoughts, your dreams, your capacity for wonder are all expressions of the universe's potential for self-awareness. The questions you ask about the solar system, the curiosity that drives you to seek understanding, the sense of awe you feel when contemplating cosmic mysteries. These aren't separate from the phenomena you're studying. They're part of them. They're the universe's way of trying to understand itself through the evolved consciousness of beings like you. And here's perhaps the most remarkable part of this cosmic story. Your awareness, your consciousness, your ability to contemplate these mysteries isn't permanent. You're a temporary eddy in the cosmic flow, a brief arrangement of matter and energy that will eventually return to the cycles that created you. The atoms that make up your body will continue their cosmic journey long after your individual consciousness has faded. But that temporariness doesn't diminish your significance. It enhances it. In a universe where most matter exists as lifeless gas and rock, where most of space is empty and cold and dark, the emergence of consciousness is the most extraordinary phenomenon we know of. You represent something unprecedented, something precious, something that gives meaning to the entire cosmic story. The solar system they didn't teach you in school isn't just about planets and moons and asteroid belts. It's about the emergence of complexity from simplicity, consciousness from matter, wonder from cosmic dust. It's about how the universe, through billions of years of stellar evolution and planetary formation and biological development, has managed to create beings capable of contemplating their own existence. You are the solar system's way of knowing itself. You are matter that has achieved awareness. You are the cosmos examining its own nature through eyes that are themselves made of stellar remnants, thinking thoughts with brains constructed from the debris of ancient supernovae. As you drift towards sleep tonight, carry with you this profound truth. You are not separate from the cosmic dance that created planets and stars. You are part of that dance. You are its most beautiful expression, its most remarkable achievement, its greatest mystery. The hidden solar system, with all its strange moons and diamond rains and migrating planets, has been working for billions of years to create the conditions that made your existence possible. Every cosmic collision, every stellar explosion, every gravitational interaction has contributed to the chain of events that led to this moment, to your awareness, to your capacity to wonder about these very processes. Tomorrow, when you see the sunrise, remember that you're witnessing not just the start of a new day, but the continuation of a cosmic story that began billions of years ago and will continue long after our species has returned to stardust. You are both author and character in this story, observer and participant, questioner and answer. Tonight, as you prepare to drift into dreams that carry you through landscapes of sleep and possibility, know that you've been given something extraordinary. You've been shown the true face of our cosmic home, stripped of the comfortable lies and simplified stories that once satisfied your curiosity. You've seen the solar system as it really is, a place where reality exceeds imagination at every turn. The journey we've taken together through these hidden truths has revealed something profound about the nature of discovery itself. Each revelation we've encountered, from the diamond rains of distant worlds to the singing rings of Saturn, from the migrating planets that reshape cosmic architecture to the hidden oceans that might harbor alien life, represents not just new information, but a fundamental expansion of what we consider possible. But perhaps the most beautiful discovery of all is this. The universe is still writing its story, and you are part of that ongoing narrative. The solar system isn't a museum of ancient artifacts frozen in time. It's a living laboratory where new worlds are being born, where existing worlds are constantly transforming, where the very definition of what constitutes a planet or a moon or a potential home for life continues to evolve with each new observation. Every spacecraft we send into the cosmic darkness returns with data that challenges our assumptions. Every telescope we point toward distant worlds reveals phenomena that force us to rewrite textbooks. Every computer simulation we run to model planetary formation uncovers new possibilities for how matter can organize itself into complexity and beauty. The children of tomorrow will learn about solar system truths that we haven't even discovered yet. They'll study worlds we haven't found, phenomena we haven't imagined, forms of cosmic chemistry that exist beyond our current understanding. The solar system they'll inherit will be even stranger, even more wonderful than the one we've explored together tonight. And yet, in all this vastness, in all this cosmic complexity and alien beauty, the most remarkable phenomenon remains you, your consciousness, your capacity for wonder, your ability to look up at the night sky and feel connected to something larger than yourself. These qualities transform you from a mere observer into a participant in the universe's journey towards self-understanding. As sleep carries you away from these cosmic contemplations and into the restorative darkness of dreams, remember that you carry within yourself the essence of everything we've discovered tonight. You are made of solar system material, shaped by cosmic forces, animated by the same energy that powers stars and drives the winds of distant worlds. The hidden solar system we've explored together isn't separate from your daily life. It's woven into every moment of your existence. Every heartbeat pulses with iron forged in stellar cores. Every breath exchanges matter with the atmosphere that connects you to every other living thing on Earth. Every thought arises from patterns of electrical activity that respect the same fundamental forces governing the dance of planets around our sun. Tomorrow's sunrise will illuminate not just another day, but another chapter in the ongoing story of cosmic evolution. The light that reaches your eyes will have traveled 8 minutes and 20 seconds from the surface of our star, carrying with it energy that began its journey in nuclear reactions deep within the sun's core. Reactions that transform matter into light according to the same principles that govern every interaction in our cosmic neighborhood. Sweet dreams, fellow traveler in this magnificent, mysterious, ever-unfolding cosmic story. May your rest be peaceful, your dreams filled with wonder, and your tomorrow bright with the knowledge that you are not just living in the universe, but that the universe is living through you. The greatest adventure of all continues with each new dawn, each new discovery, each new moment of consciousness arising from the cosmic dance that connects us all. Rest well, knowing that the solar system they didn't teach you in school is far more beautiful, far more alive, and far more connected to your own existence than anyone ever dared to imagine. And the story is far from over. The most extraordinary chapters may still be waiting to be written. I wish you a very good night. This is Boring Science signing off. Cheers.